Okay, today's lesson is really short. It's probably only, what, 4 slides? 2 pages? Something like that? 3 pages even? It's pretty straightforward. So, there is one outcome that I'm supposed to teach you, which basically means that it's basically on the difference between something called complete and incomplete combustion. And this is probably the most simple topic in the unit, so don't stress over this one too much. This is one of those times, though, where I do this quite a bit, I think, where I have to apologize and say, I've been lying to you for the last 1.5 or 2.5 years of teaching you chemistry. Whenever we talked about combustion, I wasn't telling you the full truth. I was telling you enough, like I told you what you needed to know at the time, but we actually need to fill in the blanks in this topic here and tell you more what happens truly when things happen to be combusted. Does that make sense? So when you first learned combustion in grade 10, I mean, it's overwhelming. So to keep things simple, when we taught you combustion, we said that a hydrocarbon reacts with oxygen, makes carbon dioxide and water. Although that is true, that's not the whole truth. Okay? Think about going and making a fire in your backyard. You know, it's starting to get nice out. Maybe you have a bonfire in the backyard, and you combust some wood. Well, according to the combustion equation, a hydrocarbon should turn into just water and carbon dioxide. Why are there ashes left in the fireplace when you're done? Well, that's because technically what was happening was not just that one equation, but actually multiple equations were happening at the same time. So let me talk about my notes here. In a complete combustion, which really is theoretically not possible, you produce only CO2 and water. And this is what you guys would have learned before. CO2 and water are the byproducts. But that's not actually what happens in real life. Okay. Typically what happens is an incomplete combustion. And you're going to get a combination of carbon dioxide. Yeah, you'll get that. But you'll also get carbon monoxide. And you'll also just get good old-fashioned carbon by itself, which is essentially like the soot, like the ashes that you'll see. Okay. And so not one reaction happens just by itself. Technically, 3 reactions are happening simultaneously. You might have your hydrocarbon react with oxygen, and it could make carbon monoxide. Or the hydrocarbon could react with oxygen and make carbon by itself. Or you could have what you previously learned, where the hydrocarbon makes carbon dioxide as well. 3 reactions will probably be simultaneously happening. And so you're actually going to have 2 reactants, and technically you're going to have 4 products. 4 products based on 3 different reactions. You're always making water vapor, but then you don't know whether you're getting carbon monoxide, carbon dioxide, or carbon soot. And we also don't know what percentage it is. It could be 30% of the time you make this, and 20% of the time you make this, and 50% of the time you make this. Does that make sense what I'm getting at here? It's going to be some sort of breakdown, but it's not actually what I originally taught you. It's not just this anymore. There's actually more byproducts. Does that make sense? Do you have a wood-burning fireplace at home? So you probably have some sort of damper which controls the amount of oxygen that goes in. And you might recognize that if you open up the amount of oxygen that flows inside the fireplace, it actually makes the fire roar brighter, and it burns cleaner, basically. The dirty forms of combustion are the last 2. As weird as this is to say, carbon dioxide is actually the healthiest combustion we have, which is weird, because carbon dioxide nowadays is considered to be kind of a bad thing for the environment. But worse than carbon dioxide is carbon monoxide. Do you guys know why? And it's poisonous, basically, yeah. If it takes the place of the oxygen you're breathing, it'll actually poison you. Carbon dioxide is pretty normal for you to ingest because you breathe in oxygen, breathe out carbon dioxide all the time. Carbon monoxide is a problem. This carbon by itself here is essentially soot. This is where the ashes are left over. It's very dirty. Does that make sense? So if you add more oxygen to your wood-burning fireplace, you'll notice that it roars, it burns nice and bright. That's actually the cleaner version of it. Whereas if you close the oxygen supply off, it'll actually burn for longer because there's less oxygen, so it's having a harder time to burn. But it burns a little bit dirtier in a way. And this is what I mean by dirtier. This is toxic. This will kill you. Toxic poison. I don't know which one officially it is. And this one's like all the charred ashes left over. Does that make sense? Essentially, that's my lesson. I need to show you that I've lied to you for the last 2.5 years, or 1.5 years.
Please excuse the interruption. Marley Duncan, you have a call on line 1. Marley Duncan, a call on line 1.
So combustion is not just producing carbon dioxide. It actually produces monoxide, dioxide, and soot. Carbon by itself. So I threw in just a slide here just of some common places where this might matter. Here's a picture of a wood-burning fireplace. You can kind of see, well, here's the ashes that are left over. That's the carbon that's left, the pure carbon by itself. Here's a carbon monoxide detector. If you have a wood-burning fireplace like we have one, it's important to have one of those because you'd hate to all of a sudden have too much carbon monoxide seeping into your room, and before you know it, your children are suffocating. So those are really important to have. I believe these were pictures I found just talking about how sometimes the buildup in your vehicles eventually occurs, and you may actually need to clean off. I don't even know what this particular part is anymore. A burnt exhaust valve. Yeah. So at some point the combustion might be burning so dirty that you might need to clean it off because here you can see this is all the carbon monoxide probably being given off by by vehicles. So, make sense? Cool. So here's what you do need to know. If you increase the amount of oxygen, it increases the proportion of complete combustion. So if you want a better burning fire, add more oxygen. That should reduce the amount of carbon soot and the amount of carbon dioxide you have. So like I said, if you have a wood-burning fireplace, open up the oxygen supply. It'll burn better, essentially. Okay. That being said, it does not guarantee, I don't know what this word is here, guarantee? Guarantee. It does not guarantee, though, that complete combustion will take place. There is going to be some soot, and there's going to be some carbon monoxide. So, it may now be best, then, as a summary, to no longer write combustion like this. A hydrocarbon plus oxygen gives CO2 and water. It might be better to write it like this. Your hydrocarbon and oxygen is going to produce some amount of carbon, some amount of carbon monoxide, some amount of carbon dioxide, and this XYZ ratio really just depends on how much oxygen you use. Thank you. It was short, easy. That makes sense? Awesome. I always throw this right before our first quiz because this takes all of, like 10 minutes to talk about? Less than that. So here's the plan. Okay, first thing. I mentioned this yesterday. Some of you really need to hand in some late stuff because I'm trying to work through a pile. And I just finished handing back the assignment. And I'm about to work on the last lab. If those are things you're not done, can you try to get those to me ASAP? Because really, you're now really far behind. Okay. My best suggestion though today is you need to do some practice now to get ready for our quiz tomorrow. So the first place you could work is the assignment for the unit. Now, granted, you can't do all of the assignment, but you can probably find a few questions to practice. Another thought is that I do have some worksheets as well. I would probably do those after you do some assignment questions. Okay. If you didn't complete the chalk activity worksheet, when we went outside on Monday and did the chalk activity, you probably should work on some of those. Because that's a very typical question. I will either ask you to name a molecule based on a picture, or I might ask you to draw a molecule, but since I can't test your ability to draw something, because it's not written response, what I might do is I might say how many carbons and how many hydrogens are in this molecule. So I might say in 2,5,7-trimethylheptane, how many carbons and how many hydrogens are there? Well, then you have to draw 2,5,7-trimethylheptane and then kind of add them all up. The hardest part probably, don't miss any hydrogens. No, that's probably the most challenging thing. Yeah, don't add too many. So, anyways, basically the rest of today, catch-up time / study time. Okay, really the two main outcomes. Can you draw a molecule? Can you name a molecule? Those are the basics, okay? Any questions? Cool, you guys are good.